Hello. So this video is to give the students of HAP786 workshop in Health Informatics from George Mason University a briefing on the Actionable AI Advice Project. I'm Vladimir Cardenas and I'm co-faculty for this course. So what will we do? In this video, we will download the coefficients file from the course page. The course page is openonlinecourses.com. Keep in mind that this page gets updated regularly based on students' feedback on the course. So just navigate it. You may not need to navigate it differently than what I will show you in this video. Then we will define the different columns, variables, and nuances of the coefficients file. We'll look into a minimum project flow requirement. Okay, I'm saying minimum, that's at the minimum what we need, but that does not mean that you cannot exceed it. You can add your own creativity into this project, or you can make it better, because whatever you do for this project will be something that you can hopefully show off to your prospective employers, target employers, your peers, and finally, I'll show you that this project is not only cool, it's actually simpler when you think about it, right? So I'll show you that I can do it in Excel, okay? But you will not do it in Excel, right? You will do it using your programming language of choice or your modeling language of choice. And if you want to create a front end, you will create it using a front end system of your choice. Okay, so without further ado, let's start. As we mentioned, we will start with downloading our coefficients file. You do that by going to Open Online Courses, navigating to our course page. For right now, it's here, Workshop in Health Informatics HAP786. And again, as I've told you, this website gets updated regularly based on student needs. So right now it's here. And then from the course page, we navigate to Projects, Actionable AI Advice here. And this will get you to the projects page. Okay. From the projects page, you can, let me just zoom it in, you can read about the projects, have a go at the different materials available to you and read what's actually required for the project. Okay, if you scrolled, these are the more detailed explanation of the projects. Again, this video is meant to be a briefing. I recommend that you go into the page and really understand what's needed by the project, and be a bit more, because that will be a bit more detailed than what I will give you. Okay, so if you scroll down, you will see this download Excel link for the regression coefficients. So click on that. Okay, it will take you to a OneDrive link. and then you can just click on download file here. I have already downloaded the file, so I won't download this for now, but just select where you want to save it, open it. If you're a Mac, there's a different way of downloading, which I'm not a Mac guy. Okay, so once you have downloaded that, you will see this file. Okay, without the filters, I've added those, and without the highlighted columns. Okay, so the highlighted columns are the columns that I think are important to understand this file. To understand this file and use it for the minimum intentions of this project. The other columns, you can use them if you have other research requirements, or if you want to exceed the requirements of the project. Okay, so we'll start first with the first column. It's called response. It is a list of all the antidepressants that were studied by the research team led by Dr. Farrokh Alemi of George Mason University. And it includes like 16 different 16 unique values. Okay, so amitriptyline, bupropion, citalopram, desvenlafaxine, and so on. And then the less common antidepressants are lumped together into less common antidepressants or combination of antidepressants. Okay. The next column will be C group, stands for category group, code group rather, not category group, code group. So there's an AA, which we will discuss later. AA includes demographics. AA includes demographics and measurements. I'll discuss what they are later. BXI is shorthand for diagnosis in patient. Okay, all of the diagnoses are coded in ICD-9. DXO is shorthand for diagnosis outpatient. Again, they are coded in ICD-9. Now, PX is stands for procedures, and they are coded in CPT4. So C type is code type. Okay. RX is for medications, and they are coded in generic types. Okay, so there's generic codes. And finally, you will see blanks. Blanks are a stand-in for intercepts. Okay, so yeah. So those are code groups, which we also were able to touch on code type based on that. Okay. Now, let us focus on AA. Okay, let's focus on AA, and what are the different values that they have. Okay, so AA, code group AA, have code type demographics and measurements. Let's focus on demographics first. So demographics are concerned with age and gender. Okay, so the different codes for demographics, are ager 13-19. That just means age range 13 to 19, age range 20 to 40, age range 65 to 79, age range 80 to 89, and then gender being female. Okay, if you're And then for measurements, okay, are coded values. Uh, the explanations for this are also in open online courses, but I will explain them to you in this video as well. So SR, so ADRM, SR. SR is the important part here, the last two letters. Okay, SR stands for it stands for same and remission. That means that that means the patient has a history of taking the same antidepressant and getting a remission from that antidepressant. So for example, it's for amitriptyline, the patient has a history of taking amitriptyline before and getting a remission. SN stands for same antidepressant, no remission. So the patient has a history of taking the same antidepressant and not getting a remission. So DR stands for a different remission. So the patient has a history of taking a different antidepressant and then getting a remission. DN stands for different, no remission. The patient has a history of taking a different antidepressant and not getting a remission from their depression. Okay. So NADEP means history of antidepressant use. Okay. So NADEP 2-3 means the patient has a history of taking 2 to 3 antidepressants before. NADEP 4 plus means that the patient has a history of taking 4 or more antidepressants before. NAPI means number of episodes, and so NEPI 2 plus means the patient had a history of taking 2 or more antidepressants. And then finally, NREM or NREM stands for the number of remissions. It just means that the patient has a history of taking 2 antidepressants has a history of having 2 or more remissions before. 2 or more remissions. So it's a history of having remissions. Okay? So that's it for C group AA. Okay? The next, I will skip F first. I will skip COEF and I will go straight to description. So description is the description for particular code from that particular code group. Okay, so for example, DXO4619 is acute sinusitis unspecified. AA Ager 1319 is age group 13 to 19, like as I mentioned before. So this is if you want to have a look up on what the specific variables mean in a human interpretable way, right? So now let's go to coefficients. Coefficients are logistic regression. These COEF are logistic regression coefficients. Okay, as a by now you should have had at least one statistics course. So I won't be delving into explaining what logistic regressions are in depth. You can refresh yourselves on logistic regression. And the way to read these logistic regression is filtering for an antidepressant. So let's filter for bupropion. Okay. And then, for simplicity's sake, I will put I know that the blank is an intercept, but let me just put it here. Okay. So if you recall, again from logistic regression, I will just pull up like a diagram that I can use. Okay. If you recall from your logistic regression, right, that your variable y, or logit of y, right, variable y is equal to beta 0 plus beta 1 x1 plus beta 2 x2 plus beta 3 x3 dot 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 plus dot 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 plus beta n xn, assuming there are no interactions, right? If there's interactions, there's beta 1 x1 x2, beta 1 x2 x3, but assuming there are no interactions, this is it, right? And this is how we will calculate the regression. So given this explanation, right, your beta 0 is your intercept. Okay, your beta 0 is your intercept. Okay. So in this, and then your beta 1 to beta n are your coefficients. Okay, coefficients except the intercept, right? If I remove the intercept here, so these are all your beta 1s to beta n's. Okay, and then your x's are your codes. So actually it's a combination of code group and code. So what do I mean? So here, so I will remove that I untick intercept. Actually I will, so here bupropion, y of bupropion is equal to beta 0, which is negative 3.12, right, plus, and then I will select all except the intercept, plus beta 1 will be negative 0.16, right? So it will be negative 0.16 times DXO let's just put it that way. Let's just concatenate them, right? And then the next coefficient is negative 0.1 times AA Ager 2020, and then let's do at least 3. Okay, the next is negative 0.08 times DXO 30,000, right? Dot 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 plus dot 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 until you get to the end of this, which is Rx, which is what? Sorry, plus 0.21 times Rx. Okay, so when you process all of that, that is bupropion. Okay, as you see, this is a very simple project. It just requires you to multiply things together and then add them up. That's it. That's really is it. And then after you got y of bupropion, we will create the probability of bupropion. So again, the probability of bupropion, which is just based on open online courses and based on Montana, on any other book that you can find, is just this formula, which is odds over 1 plus odds. Okay, so it will be odds over 1 plus odds where odds is equal to exp, or e to the power of y bupropion. Right? E to the power of y bupropion. So that's it. So again, if you do that, probability of bupropion is equal to e to the power of y bupropion over 1 plus e to the power of y bupropion. Okay, so then so checkpoint. So we have downloaded the file, we have defined the columns, okay, and we were actually starting to discuss the minimum project flow when we were discussing the calculations involved for getting the prediction of for each antidepressant. Okay, so now let's discuss about the minimum project flow. So at the minimum, the project requires you to do this, and go read for more details, and you can of course make it fancier or more complicated to get hopefully better results. But the initial results that we are looking for are these. Okay, so you get a patient history in a CSV format. So it will be like history.csv. This patient history will be generated by you guys. Okay, and you assume that it came from like ChatGPT or another agent that is responsible for retrieving patient history or patient features, right? The features that we need to run the regression. And then you have to create a modeler that will run all the regressions for all the antidepressants given this patient history. Then you will come up with up to 16, we will come up with 16 regression results. So you will have a result from amitriptyline, you will have a result for bupropion, and you will have a result for others. Okay. And then based on these results, you will then select the antidepressant with the highest probability of remission and provide the recommendation link. Okay, so what is the recommendation link? That is actually the last highlighted file in this file. So the recommendation link, for example, for bupropion is this study. So you will provide this recommendation, meaning if you are bupropion, here is the how bupropion should be used, or the history and stuff like that. So you give this to the user. The user for this will probably be a clinician or a psychiatrist or someone that can interpret this this article. Okay. You can be more fancy about it, like pull up, give them an interactive link that they can go through, that they can just click and then go to it, or you can actually list down the contents of the site. It's up to you. Okay, it's your creativity. Now there will also be an option, there will also be a scenario where there is no selected antidepressant, right? So, well, there's also a scenario where there's nothing to be done, that cannot be. So if there's no match, right? No match. So the definition of no match will be, let's go to Actionable AI again. Yeah. The definition of no match is an antidepressant. If all antidepressants have less than 10% probability of response, right here, then you have to say this, right? You have to say this item. So if there is no match, then we will provide a recommendation that they should seek further advice, right? Because we don't have data on what to do for this particular patient, which is definitely going to happen given given the diversity of the human experience, right? So this one will be yellow because you didn't have a recommendation. Okay. So those okay. So sorry, orange, because I already used yellow for in progress. Okay. And then this one is green, and then no match, right? So again, at minimum, patient history, create a modeler and run it, get the regression results, process it, see if you can provide the recommendation. If you have no match, then make them examine other options and get more advice, right? So that's what your AI is gonna do. Okay, checkpoint. So we've done the minimum project requirements. Now, as I've told you, when I'm thinking about this project, it seems like at least the bare minimum requirements are pretty simple. If it's just logistic regression, it's just multiplication and addition. And then, because most programming languages already has exponents like exp functions, you don't even have to hand calculate converting those log odds, which is like multiplications and additions, into probabilities. Okay, so it's pretty simple, and I can even do it in Excel. Let me show you. But I don't recommend that you do it in Excel. I'm just using this to give you an idea of what to do. But I don't recommend that you do it in Excel, because as powerful as Excel is, it's not sexy when you're trying to apply for the job and then you said that I created my AI model in Excel, right? You want it to be like a reusable AI model. So the first thing that you have to do is create a patient history. Okay. So you need to have like a patient ID. For this particular example, let's just make the patient ID numeric, and let's say we have like, I don't know, 40 patients. And each of those patient IDs will have a value of the specific medical history. Okay, so again, the medical history will be the code and the code group. Okay, so let's put that in a value list. I'll put those in a value list sheet that I've created. Oh, it's filtered. That's why it's not. Okay, there's no more filters. There are. Let's see. Sorry, I need to make sure that the filters are reset. Okay. Right, no more filters. So again, the unique variable will be a combination of C group and code Y, because there's DXO and DXI. So 3098 will appear twice, one for DXO, one for DXI. So we need to make sure that those are different. So we will copy these and then paste them into value list. So C group and code. Okay, so let me just increase the zoom here so that you can see. Maybe 145 is better. Okay. So now we have DXO and code, so we just have to make it like a variable or a feature, right? Right? Which is, let me just filter this. I wanted to make sure that the blanks are here. Okay, cancel. So maybe the code. There should be a blank code. Okay, so it will be just like concatenate this one. Sorry, equals. I forgot equals. Equals concatenate DXO and code, and then just copy away. Oh, there you go. The intercept is okay. Then we got these. I can now remove these guys. Right? Okay, sorry. Base values only. Okay, and then I can remove these guys, delete, and then I can go to data and remove duplicates. Okay, and I'll remove blank spaces. Sorry. Okay, so these are all the features, the unique features. Right? Let's see. Let me just find intercept, because last time I did this, intercept did not work properly. Okay, intercept is, yep. Okay, so now it works properly. So because this is a very long list. This is like 459, and we have a special process for intercept. I would rather delete intercept, right? Delete that here in this value list, and then put it at the very beginning, because we do have a special process for the intercept. Okay. Just imagine doing this in Python or R. So it will be much quicker, or you don't even have to know where they are, and that's why it's more powerful. Okay. So these features, I will now, our patient history should have all of these features, right? Whether they have 1 or 0. So they might have this diagnosis, or this, or in this age range, right? And so on and so forth. Okay. So the intercept, in particularly for matrix multiplications, which is what I will do, the technique for an intercept is just for the first matrix, just put all ones, right? And then we will use the values in the modeler for the actual intercept. So for example, in the model, the intercept is -2, because 1 times -2 is always negative. It will always be -2, and we automatically get -2 as the value of the intercept. Yeah, you'll see later. Now, each of these things will have a value from 0 or 1, because these are just binary variables, right? So we can just, to generate it, we can just randomize. Your randomization will be more complicated. Why? Because, for example, if you are already in the age group 20 to 40, you will never be in the age group 65 to 79, 80 to 89, right? So you will have a slightly more complex generation file, patient history generator. But in this example, since it's Excel, I'll just use random values. So there's a chance that there will be a patient that is both age 20, 65, right? But additional processing can limit that. So I will just do a random number, and then round that to a whole number, right? So I will be able to like generate all of these 400 patient history values. Okay? Imagine. Okay. And then I will now replicate that here. Okay. So we have randomly generated patient demographics. Again, you might have to be able to make it more intelligent. So age are dummy variables. That means they cannot be are mutually exclusive, right? The antidepressant histories, some of them are, it's also mutually exclusive, right? If you are already in 4+, you cannot be in 2-3. Okay, so but for this example, again, you can do this way. All right. Now for our modeler, we will get now our value list, which is our features, right? Our feature, and then a list for our another value list. A list of our antidepressants. Okay, you need antidepressants. So okay. So these are our list of unique antidepressants. It's too long. I just make it other, right? The less common antidepressants, I'll just make it as other, so that's easier to understand in the code. And I will put those in the modeler. The idea here is now you will copy the exact value of each of these parameters from the coefficients file. So for example, citalopram is our first. Citalopram has an intercept. Let's go to intercept. Citalopram has an intercept of 0.04, right? So should be the modeler will have 0.04, negative 0.04 here, right? And if it's missing, for example, this is 78907 is missing, just put 0, right? Meaning the model does not need that variable, right? So that's the idea. But again, for this particular demo, I'll just put in random numbers. Right? I'll just put in random numbers. So between a random number between negative 10 and 10. Right? Okay. And then just copy it all throughout. And then sorry. Okay, so there you go. You have random variables. You also replicated a variable that is like 0, so that's cool. I would probably also round this to 2 decimals. Right, just to be like easier to model. Okay, so here you go. So this should, in your own project, this should reflect whatever is in this coefficient. So find a way to do that. Okay, but for this demo, I don't need to do that. Okay, so now we'll do regression results, but I don't know why it's there. Okay. So regression results is just matrix multiplication. So I will get your patient name, okay, and your models. And I will just multiply the 2 matrices together. I haven't practiced this, so this might not work. So emote, let's see. But again, I think Excel can do it. I really believe in Excel. Sorry. And just go to emote. Okay, I'll go here and select this, and then make sure that I get this correctly. Okay, B2 to QQ41, that seems right. And then the second array will be the model, which is this one. Then click OK. That's it. So these are your regression results. Then we can copy that and rename this probabilities, right? Prob and reco, right? So in here, instead of matrix multiplication, we'll use the exp, right? So it's exp of this over 1 plus, okay. Is that correct? Is that correct? And we go to just make sure that it's percent. And there. So there's a lot of 100%. I think I didn't get this formula right, but you can see, and then you can just take the recommendation, right? Is equal to maps, right? Maps of this. And then no reco is equal to right, if this is less than 10%, then no recommendation, right? Otherwise it's recommend, right? Something like that. And that's it. That's how to do it in Excel. So again, checkpoint, we've covered how to think about the problem. It's a very easy matrix multiplication example. The challenge is to make sure that you're testing it on correct data. So the challenge will be probably creating the right patient history generator, creating a more optimal flow for your modeling, and then creating an optimal recommender where it will find whether it will recommend an antidepressant or not. If it recommends an antidepressant, provide the link for further information on that antidepressant. If it not find an antidepressant that's higher than 10% probability, then just mention the text that Dr. Alemi mentioned in the course page. So that's it. Good luck, and yeah, hope that answers your questions. If you have any other questions, don't feel free to talk to your project manager so that they have they can analyze the issues, and maybe that kind of issues have already been solved by other teams, and then filter them and finally relay to the teaching staff questions that we need further help from us, right? So good luck, and yeah, more success.